This video shows how to conduct a chi-square test of independence in Excel. So first of all, let's just review what is the purpose of doing a chi-square test of independence. So with a chi-square test of independence, this is very similar to a correlation where you're wanting to see if there is an association between two variables. However, for the chi-square test, those two variables are both nominal variables. So they're both variables that indicate a certain group that someone falls into. With the correlation, on the other hand, both of your variables are interval or ratio level. They're not grouping variables. So here we're going to find out if two nominal variables are related using the chi-square test. Now this is our data that we're going to be using. If you take a look through this data, there are only two variables in here that are nominal. First, this manager training variable indicates a 0 for the managers who did not go through training and a 1 for the managers who did go through training. So that is a nominal variable. It's a yes or no type of response. This next variable right here is the manager's function. So what function did the managers work in? And if you look here in the filter, you'll see that there were 4 options for function, 1, 2, 3, and 4. This other tab here shows what those 4 numbers represent. Commercial is 1, research and development is 2, sales is 3, and global is 4. So let's get to looking to see if manager training and manager function are related. This would tell us if managers in certain functions are more likely to be trained than managers in other functions. So that's really the business question that we are addressing here. Are managers in certain functions more likely to receive training than those in other functions? This is an important question if you're trying to make sure that managers across functions are receiving training. So that's our question there. I'm just going to highlight that to keep that in mind. So the first thing that I would do to do a chi-square test of independence in Excel is I would create a pivot table of the counts of these subgroups. So first we need to know how many people in each function were trained and not trained. So that's what we're going to create a pivot table to do. So that's step 1, create a pivot table of the counts. So I'm going to highlight my 2 columns and go to Insert, Pivot Table, and I'm just going to click OK. The pivot table will be located in a new sheet. Well, don't just click OK. First, go into this table range box, and you have to highlight your data there. Then click OK. Okay, so you'll see here on the right, we have manager training and function. So manager training, I'm dragging into columns. And function, I'm dragging into rows. Now you can flip it. It doesn't really matter which one you put in columns and which one you put in rows. Then you're going to take one of them. Again, this doesn't matter. You should get the same numbers regardless. Take one of them and drag it into values. Now you'll see this is automatically showing the count, which is what we want. So this is the pivot table that we need. However, I would set it up to where it's a little easier to read. These numbers, 0 versus 1, that was manager training. So I would put above here, training. This is no training, and this is yes training. I would also use this filter right here to get rid of the NAs and the blanks. Then function was the 1, 2, 3, 4, so I'm going to put function. And let's recode what each of these numbers are. So 1 is commercial, 2 is research and development. So I'm going to change 1 to commercial, 2 research and development, 3 was sales, and 4 was global. This is just to help me keep track of what I'm looking at. Now, to do a chi-square test, we need to compare 2 different sets of values. First, we need to look at what we call the observed or actual values. That's what this pivot table is giving us. These are the values that we actually observed. So I'm just going to put a note up here saying observed. Now here, I am going to, we need a second table. This time, we are going to create a table showing similar numbers, but the numbers are going to be what we would expect to get if there was no relationship between function and training. So if there was no effect of function on training, this is what we would expect to see. So I'm going to call these the expected values here. So I want the table to look very similar to what we have here. So I'm going to copy and paste these labels just so that it's set up the same way. And this was training. Okay, now in order to get the values, to fill out these values, what we would expect to see if there was no relationship, there's a formula that we're going to follow. That formula is in this stats review PowerPoint. This is it right here. It's row total times column total divided by sample size. So that's what we're going to be using. So let me just type this out for you. Row total times column total divided by total sample size. So we need to fill out these 8 boxes right here. Okay, so for commercial, I'm going to do equals, open parentheses. What is the row total for commercial? That's this 329 right here. So I'm going to type in 329 times, and then I need the column total, which is 323. Close parentheses divided by the total sample size, which is this 688 right here. And let me enlarge in this a little bit so you can see these formulas. Okay, so then for research and development, I'm going to do equals, open parentheses, the row total, which is 128 for research and development, times the column total, 323, divided by the 688. The denominator will always be this number here, 688. Okay, so equals for sales, the row total is 137, times the column total is 323, divided by 688. For global, the row total is 94, times the 323, divided by 688. And then we're going to start on the yes group. So the managers who went through training in commercial, no open parentheses, for commercial, the row total is 329, times the column total is 365, divided by 688. For research and development, the row total is 128, times 365, divided by 688. For sales, the row total is 137 times 365 divided by 688. And for global, 94 times 365 divided by 688. Okay, so now we have our observed actual values here and our expected values here. I'm actually going to rename observed to observed/actual, because I think that's what Excel actually refers to it as, the actual range. Okay, last thing we need to do is conduct our chi-square test. So there is a function in Excel called chi-test that will take these numbers that we have here and give you a p-value, your significance value, your p-value. Now remember, just like with all these other statistical tests, if your p is less than 0.05, there is a relationship. If your p-value is more than 0.05, there is not a relationship. Like I said, this chi-test function gives you the p. So let's do the chi-test function. So we're going to do equals chi-test, and you'll see it pop up. Then you'll open parentheses, and it's going to ask you for the actual range. That would be these 8 numbers right here. So we're going to highlight those 8 numbers. Then we're going to do comma, and now it's asking us for the expected range, which is what we calculated. So now I'm going to highlight these 8 numbers. Close parentheses, enter. Our p-value here is greater than 0.05, so there is not a significant relationship. So, to answer our business question, managers across the 4 functions are being provided training in the same proportions. So managers in certain functions are not necessarily less likely to get trained than managers in other functions. Now, once you have this information, I have an example in the slides of how you could write something like this up. We're just going to keep things simple for the purposes of this class. You could just say something like, no association was found between training and manager's function, and then in parentheses, P is greater than 0.05 because our chi-test value right here is greater than 0.05, and that is the p-value. So this is how I would write that up. And that concludes this video.